notes go. So maybe it's too much stuff for that. It takes a lot of time, which you might not have.
So stepping aside from the practice exam, I did have a question about chapter 3, number 128.
Okay.
I got the right answer, it's just took me a while to get there. And
Okay, let's take a look at that.
let's see if I can do it.
Chapter 3, number 128. What section is that?
The last section.
Last section? It's the one of the chapter 3. 128.
Just consider general questions.
Yeah, well, the only reason I ask is because they don't do it, all right. Well, there is a question I was asked the other day. This is a dimensional analysis problem, so in active example 3-29. So let's just take a look at active example 3-29 first. Okay, here's active example 3-29. But this doesn't look right.
No, that's not it.
Not it. Let's try it one more time.
Oh, that's the practice exercise. Try scrolling up. Might be on top of that.
All right. Yeah, that's true. Let me see it on top. Oh, there it is. Okay, here it is. Active example 3-29. This dimensional analysis. Suppose you have just landed a part-time job that pays $9.25 per hour. And so the first thing we do, when we look at the dimensional analysis, or any problem for that matter, is to figure out the conversion factors. So here, the first conversion factor that we're going to get is $9.25 per hour. $9.25 per hour. This way, we could use it in two ways. We could use it this way, which converts hours to dollars, or we could flip it upside down. If we flip it upside down, it converts dollars to hours. I'll just write it one way here. You'll work 5 shifts each week. 5 shifts per week. Actually, how many people got this problem? Yeah, this is only 3 or 4 people is kind of behind to get. What you want to do, well, if this is chapter 3, if you're already on 4 and 5, but if you haven't gotten it, if you try, actually, let me rephrase that. How many people tried this problem? Okay, well that's better. So yeah, you try this, and then we just write down the information. 5 shifts per week. The shifts are 4 hours long, and so we can write 4 hours per shift. 4 hours per shift. And then what else? You plan to save all your earnings to pay cash for a 50-inch 1080p smart plasma HD TV that costs $1082.49. So we want 1082.49. Okay, this is a fixed amount, tax included. Okay, you are paid weekly. How many weeks must you work in order to save? And so what we want to do is, the question is, how many weeks will it take to purchase this TV? And so this is fixed. These are some ratios. Sometimes we start off with a ratio, but if there's a fixed quantity, we want to start off with a fixed quantity. And so 1082.49 is what we're looking for, dollars. And I don't know what the strategy, I don't even care what the strategy is. I normally don't think about the strategy. I just think about how I can cancel out dollars here, or dollars of TV. Dollars or dollars of TV or whatever. In this case, just dollars. So is there some way I can convert? Yeah, I can go from dollars to cents, or dollars to quarters, or dollars to nickels. There's a whole bunch I have memorized, right? dollars to $20 bills, you know, a whole bunch that you have memorized. But in this case, we have something specific that we can do. We can just go from dollars to what? $9.25. And so the dollars cancel. That just gives us hours. So this is how many hours you'd have to work. And if that's all we're interested in, the number of hours we have to work, then we're done here. But that's not what we're interested in, because we don't work continuously. And it turns out we need to get rid of hours next. So we could go hours to minutes. Would that be good? No, hours to days? No. We want to go hours to. But you know, just if you're stuck, then try hours to minutes or hours to days, or try something. You know, it's better than not trying anything, you know, even if it's a dead end. Because if it's a dead end, then you know it's a dead end, and then you don't want to proceed that way. And so that's actually beneficial. You know, the thing with experience, and this is something that you sometimes don't get, you know, and sometimes people think, for some reason, some people think that mistakes are bad. No, mistakes are good, because that's how you learn. You learn by making lots of mistakes. The people who've been doing this for like 30 years have made all the mistakes. They know, okay, I gotta avoid there, I gotta avoid there, so they know which path to take. But you know, when you're learning, you gotta take the wrong path sometimes to figure things out. So, you know, and that just means trying something. Anything, and if it turns out wrong, then with dimensional analysis, back out. And so anyway, here we can go hours to shifts. So we'll just flip that around. You know, one shift equals 4 hours. And so the hours cancel. That tells me how many shifts, but I don't work continuous shifts, just 5 shifts per week. And so I see that I'm going to get rid of shifts this way, 5 shifts per week, and then what's that? So let's see how many shifts or how many weeks we have to work. And so what we could do is we could just do this one step at a time, just with the calculator. 1082.49 divided by 9.25. You know, this person would have to work a total of 117.02 hours. Or in terms of shifts, we'll divide it by 4 hours per shift. They'd have to work 29 shifts. Or divided by 5, and we'd see that they're going to work 5.85 weeks. How many sig figs are we allowed? $5.851 weeks. But they're asking how many weeks, because let's see, you're paid weekly. And so if they're paid weekly, then they're going to work the entire week, which means that this is going to be 6 weeks. Now, let's see. The last part of this one is this. You might also be interested in knowing how much cash you'll have left for video games. So actually, this person's working an extra bit of a week. You know, 0.149. Do you see that? And so they're going to get paid for that 0.149. And so let's see how much money is left over to spend. So the leftover cash is, well, 6 weeks. It's going to be just 6 minus 5.851. It's going to be 0.14, so 9 weeks. So they're working this many weeks extra. And so if they work 0.149 weeks, then let's cancel out weeks, because we want to know how many dollars are left over. So what should we go from weeks to shifts? So we'll go 5 shifts. I'm just kind of working backwards. And then shifts to shifts to hours. And so we have 4 hours per shift, and then hours to dollars, so $9.25 per hour. And so actually I didn't clear my calculator, okay, so I'm just gonna go ahead and punch this. So my calculator is actually carrying all the digits here, No, actually, yeah, I did the subtraction. Did I do the subtraction? Maybe I didn't. Maybe I didn't carry all the calculators. It doesn't matter, as long as I carry an extra one. It's fine. 149, that would minimize round off, times 5, times 4, times 9.25. And they would have $27, even though we're only allowed 2 sig figs. How many sig figs are we allowed? 2 sig figs. This is going to be $27.56. And so to round this to 2 sig figs, we would say $28. But you got to be careful, because if you go out and spend $28, it's rounding error. Right? You better not spend $28. But the sig figs, this is not, this is where sig figs kind of fails, in a way. But it depends on the certainty here.
So that's just the first part.
Yeah, this is the first part, so let's go to the actual problem. So this is, we should take a look at active example 329 first, and then see what the difference is. So in active example 329, you calculated that you would have to work 6 weeks to earn enough money to buy a 1082.49 television. You would be working 5 shifts of 4 hours each at $9.25 per hour, but alas, when you received your first paycheck, you found that exactly 23% of your earnings had been withheld for Social Security, federal and state income taxes, and workers' compensation insurance. Taking these into account, how many weeks will it take to earn 1082.49? And so we have this extra factor here that is, this is what we call the gross earnings, and then we have something called net earnings. Net earnings is after tax. And so after tax, it's like your income tax, You're going to work 6 weeks for this TV, but you're not just working for the TV. You're not just working for yourself. When you're working 6 weeks, you're also working for the government, right? And so out of that, the government needs their cut. And they say, you work maybe 2 months of every year for the government, and 10 months of the year for yourself, I think. Maybe it's more or less, depends. And so we have to make sure the government gets their cut, and then that means we're going to have to, the cut is for benefits or whatever. So let's go ahead with this now. We have to add this. The one additional factor is 23%, and so you should know about percentages very well. So how can we write this? 23% is what? 23% withheld. I don't like 0.23. I don't like decimal form, because I like to write things in terms of conversion factors. You could write 0.23 out of 1. That's okay. 0.23 out of 1, I'll take that. But what are the units here? This is where people screw things up. People screw things up because they don't label. I see this all the time. People just multiply by 0.23, or they'll multiply by 23 over 100. But what is it? 23 what over 100 what? That's a percentage, right? Percentage are parts per 100. ppm is parts per. It's exactly the same. All these are exactly the same. Parts per 100, parts per million, parts per billion. And it's going to be 23 what over 100 what? $23 over $100, and just leave it like that. $23 over $100. This is where people run into difficulties, because in advanced problems you have to label things with a lot more detail than in basic problems. In basic problems, you don't really need. A lot of people, what I see on tests all the time, I see people don't write any units. They just have the numbers and they just calculate it. You aren't going to get very far that way. I mean, maybe Chem 4, yeah, okay, you can probably get through it, but you aren't going to get much farther. until you start labeling. And then if you want to do advanced problems, you really have to label it a lot more. And so this is $23 what?
Withheld.
Withheld?
For $100 earned.
Yeah, good. $100 earned. That sounds good. $23 withheld. Now, with percentages, we gotta, sometimes we gotta think, you know, if $23 are withheld, how many, you know, earned, $23 out of 100 leaves you with how many dollars left over to spend for the TV? Yeah, you'd have $77. What should we call that out of $100? So out of every $100, we're going to have $77 left over to spend for the TV. What do you want to label for that one? Net gross, yeah. You can say $77 net over gross earnings. All right, so this is a very common problem. This is a very common problem, like for example in energy, you know. If you consume a 1,000 calorie candy bar, are you gonna have 1,000 calories to climb a mountain or ride a bike? No, there's a certain percentage of that energy is gonna be converted into work, what we call work. And the rest is gonna be converted into what we call heat. Energy is conserved, so 100% of that energy is conserved, except there's only a certain percentage of that energy you can actually do work with, and that percentage is, it's the same thing with light. You know, if you have a 100-watt light bulb, you aren't getting 100 watts of light. You're getting a small wattage of light, and the rest is being radiated as heat, which we call infrared radiation, that kind of thing. And so this kind of percentage happens in chemistry over and over. So you got to master these kind of percentages at all times, because when we do that, let's say you have a 1,000 calorie candy bar, you know, what percentage is actually converted into work? And so then we got to label things properly. And so this is where people get stuck. So we have this additional factor. And so what we need is, we need 1082.49 gross earnings, or 1082.49 net earnings. And so we need this has got to be net. And so we gotta get rid of dollars or net dollars. How can we get rid of dollars or net dollars? Well, we have it here. We have 77 net dollars for every $100 of gross earnings. The gross earnings are going to come from the job, and so now we got the net dollars cancel, and that leaves us with just gross dollars. And so the gross dollars are going to come from your hourly pay. In your hourly pay, you're paid $9.25 gross earnings per hour. So $9.25, and then the rest is pretty much the same, except, you know, in this particular problem, we had to add additional labels to the quantities, otherwise it's hard to solve. And so and so what do we do from here? We go from hours to shifts, and then shifts to weeks. We're done. So let's go ahead and calculate it now here. And so we have 1082.49, 1082.49 times 100 divided by 77 equals. All right. So to purchase this TV, you have to earn $1,405.83. And so you have to earn $1,400 or $1,405 or $1,406 to get enough money to buy this TV, because the additional $300 or $400 will be going into taxes to the government. Not taxes for the TV, because the TV, so you're being taxed. Yeah. Okay, divided by 9.25, divided by 4, divided by 5. And so that comes out to 7.599 weeks. 7.599 weeks, which means you'll have to work 8 weeks. 8 weeks to rent the TV. And so that means an additional 2 weeks to pay the government. 6 weeks to pay for the TV, 2 weeks to pay for the government. Cut. All right, other questions from chapter 3 homework? You have none? Then let's take a look at other questions from other homework or the practice test. Practice test. Well, let me tell you the other reason I don't want to cover the whole test. Because I don't want to cover the whole test because if I cover the whole test, that means you didn't work to look to find if the answer is correct or not. And if you don't work to do that, then even though some people say there's no such thing as a dumb question, there isn't, but there is such thing as just being kind of lazy in a way and not really working together. But anyway, we could do this. How do people check their answers in science? We usually check it by peer review. And so if we do something like this, Charles' law was derived from experimental observations, we could just see, what do the peers think, true or false? True. And then if somebody says, well, if most people say true and somebody says false, then we got to discuss it. Why do you say it could be the person that says false is correct? They have a strong argument, and everybody else is following the herd. Or maybe the person who said false. Did anybody say false? Well, we can do this. It depends on what you want to do with the time. We have limited time. So do you want to go through every single question, or do you want to just target certain questions? Which questions do you want? And then we can discuss those in more detail if you want. Which questions do you want to go through?
What if we just do all of them quickly, and then if there are ones that we are having questions on, we can
Okay. 2, scientific method. Okay. 3. Just tell me the letter you got. 3. If you're a dissenter, let me know. 4.
Is it 3 probability? Yeah. Oh, I think so.
Yeah, flammability is correct. 4.
True.
Physical properties of the hydrogen 1 and hydrogen 2 isotope. True? Most people?
True.
True. Smallest piece of an element is
Wait. No.
C.
An element? None.
None? Okay, which is it? C and D. D? C or D? C. Okay, if you said C, or if you say D, you're going to have to come up with some kind of argument to convince somebody. And so, give me a quick argument.
They're not elements.
Well, there's some-
Yeah, electrons are not elements. Is electron copper or electron silver? No, electron is not an element. Electron is part of an element.
But elements
If you have
are
10 electrons, is that fluorine? No. If you have 12 electrons, what element is that? None. If you have a lightning bolt, you can have 12 electrons, right? Yeah, in fact, in a lightning bolt, you have a heck of a lot more than 12 electrons. You remember the CRT? What is the CRT? CRT, did you guys review yesterday's notes? No. CRT is the acronym for well, I'll just, it's okay. cathode ray tube. When you guys have time to review, cathode rays are important because cathode rays were discovered to be electrons. Cathode rays are beams of electrons. It's an electron gun. So it's shooting electrons. Does that mean it's shooting copper, gold? Can I collect those electrons and make gold? No.
Question, what would you say the smallest piece of an element is?
The smallest piece of an element, because once you have an electron, tell me what element that came from.
But elements are made from atoms, which electron
The
is
smallest
small,
piece
but-
of an atom is not actually. This is a trick question because do you know the protons and neutrons can be broken up into even smaller particles, like quarks? Have you heard of quarks, bosons, that kind of stuff? No, for us chemists, we're just going to break it up into the three main particles, and those three main particles, the electron hasn't been broken up, but the proton, neutrons have been broken into even smaller particles. And so, once we get to subatomic, define an element for me. What is an element? Give me a definition for an element.
Element is a series of atoms with the same properties, where the number of protons.
Yeah, an element is going to be defined by its properties. So, yeah, that's good. Copper has certain characteristic properties. So, okay, rather than put element, I'm going to say the smallest piece of copper, because copper is an element, correct? The smallest piece of copper is the electron. Okay, is an electron still defined as copper?
No, but it's the smallest piece of the atom, which is the copper.
But it's no longer copper. The smallest piece of copper is the copper atom. The smallest piece, the atoms themselves are made up of smaller particles. But I see what you're saying. What you're saying is the smallest piece of this, but we don't know what the smallest piece can be broken up into, because these things can be broken up into even smaller pieces, but we're not. And in fact, that's what they're looking. And one of the experiments that they're looking if the proton can spontaneously decay by itself into even smaller pieces. So they have these huge tanks of water deep underground, looking to see if any evidence of proton decaying in a hydrogen atom. But the thing is, maybe I should have phrased it differently. What is the smallest piece of copper that you can have? The smallest piece of copper, 1 gram, half a gram, 1/10 of a gram.
So I just looked at the definition of the philosopher in the book. Element, a pure substance that cannot be decomposed into another pure substance by ordinary chemical means. Does that mean that neutrons, electrons, and protons are not pure substances? Pure substances?
No. Neutrons, protons, and electrons are pure substances, but those are subatomic particles. And we're setting the ground rules. The subatomic particles, i.e. this, are important to know because that's going to dictate the behavior of the atoms. But the ground rules are this. The subatomic particles are the realm of the nuclear chemists. The nuclear chemists play by a different set of rules. The nuclear chemists don't play by electrical forces. In fact, nuclear chemists ignore electrical forces. So for example, if there's a charge on an atom, like for this, an alpha particle, to a chemist is this. To a nuclear chemist, it's this. The difference is the nuclear chemist doesn't care about this charge. The chemists care about this charge. The reason is because Coulombic forces are very, very weak compared to nuclear forces. Nuclear forces are much stronger. And so what they can do is they can ignore the Coulombic forces. But do you know alpha radiation is very dangerous?
Yes.
Alpha radiation is extremely dangerous. Is it extremely dangerous because of its nuclear properties, or is it extremely dangerous because of its chemical properties? Alpha radiation. Alpha radiation is extremely dangerous because of its chemical properties. It's because of this charge here. This is why alpha particles are so dangerous. Alpha particles form from radioactive substances, but the alpha particles themselves are not radioactive. The alpha particles themselves are chemically reactive. We're going to learn this more later. But alpha particles, this is why alpha particles are so dangerous, but it's so easy to shield yourself. If you have a piece of paper, you can shield yourself because the alpha particles will attack the paper. You know, they're going to attack the thing that's easiest to attack. Paper's easy to attack. We'll talk about it later. And so, protons and neutrons and electrons are pure, but you know, you can have pure, but it's a little bit tricky because of this. You need to know a little bit more. You know, you can't have a bottle of protons and say, I'm going to sell you a bottle of pure protons. That would just, and the same thing, you can't bottle up electrons and sell it as pure electrons. The amount of voltage, you know, if you bottle up electrons, you're looking at, you know, I don't know, a trillion volts right there, you know, something like that. And you'll have a huge static electricity lightning bolt occur. I mean, the voltage for lightning, what is the breakdown voltage for air? Any physicists out there know what the voltage breakdown for air is? I think it's like 25,000. I used to remember the number, but I think it's about 25,000 volts. You know, that cause a lightning bolt. But anyway, you build up too much charge on one end, you're going to get a lightning bolt, basically. And so we can't bottle up these things as pure substances. We can bottle up elements. You can get pure gold, you can get pure sodium chloride, you can get pure water. And so we need a little bit more definition. And so these really wouldn't be. Yes, I mean, in theory, yes. We don't expect any impurities or contaminants. All right, 7. Coulomb's law. What did you guys get? Oh, actually, I skipped one. 6. 7. 8. Yeah, nuclear forces. If you take physics 1, gravitational forces are the most important. Chem is gravitational forces. Yes, gravitational forces are important for isotopic fractionation, like in the bottom of the ocean versus the top of the ocean versus at sea level versus way high up in the ozone layer. You know, their gravity is important because that separates things, heavy elements from lighter elements. But in the laboratory, it's not at all. But when we're dealing with nuclear radioactive substances, this is the all-important. This is called the strong force. Electrical forces are considered weak. Gravitational are even weaker. 8. 9. 10. 11.
False.
Sounds like most people say false, but what do you say?
1 cubic centimeter.
Yeah, the definition is 1 cubic centimeter, not inch.
Yeah, false.
Okay. 13. Why is 12 false? Because of the uncertainty. In science, we look at these numbers like this. Whenever we look at a measurement like this, we think about the range of uncertainty. And so automatically, I think 24.5 to 25.5 milliliter range. This one's going to have a much more precise range.
Wouldn't that be dependent on which way you read it? Because if you're starting precise and then going big, it would hold true. But if you had it the other way around, where 25 milliliters equals 25.0, that would be untrue.
No, well, either
You already
way.
defined that it's 20.5.0.
I didn't define anything. I'm just saying 25.0 is equal to this. It's either way. It doesn't matter which one I start with. I don't say if, then. This is not an if-then statement. This is just inequality. It doesn't matter which one I start with. It's false. $13. 14.
4.
D? Yeah. These. Which atom's heavier? Hydrogen? Helium? Well, which one is it? Hydrogen or helium? Helium? Anybody say hydrogen? Yeah, helium's heavier. Which one's bigger? Which one's bigger in size? Hydrogen. So be careful. I know I told you which one's bigger, which one's smaller, but that's size, dimension, not weight.
Is hydrogen bigger just because it wants to react more? Is it just
No. Hydrogen's bigger because of this. It's very simple. And we're going to look at this pretty soon. How many protons does hydrogen have? One proton. What's the charge on the proton? Where is it located? Nucleus. What's the charge on the electron? Okay. Is there a neutron? No, there's no neutron. And so this is Coulomb's law. Coulomb's law says the force is equal to, I didn't write Coulomb's law for you, but it's on the charge on the proton times the charge on the electron divided by the distance between the center of these squared. The distance squared between the center. And so what's the charge on the proton? It's 1. The charge on the electron is -1. And so 1 times 1 is -1. And negative is attraction. You know, opposites attract. Okay, let's go to this. Helium-24 is very common. This is the most common isotope of helium. Because how do I know this is the most common isotope of helium? I can easily tell it's the most common isotope of helium by looking at the periodic table. How? Because the average. What is the average mass of helium? Well, let me just pop up the periodic table there. The average mass is 4 for helium, which means that it's got to be mostly. In fact, you know, this is going to be, when I look at that average mass is 4.0026. I got to look at what other isotopes are present, but that's really almost right on. And so it's got to be practically all 4. And it is. And so this is helium. For what's in the nucleus?
Protons.
How many protons? 2 protons and 2 neutrons. And so what's the total charge of the nucleus? Positive 2. And then how many electrons? 2 electrons. Now the electrons stay apart from each other. They stay apart from each other because they're both negatively charged. So, but this electron not going to be attracted to this electron, but this electron is going to be attracted to the nucleus. Now let's look at the force of attraction. The force of attraction is going to be the same as this? No. That's because now Z of the proton is what? Z of the proton is +2. Z of the electron is the same at -1. The distance, let's say the distance is the same. If the distance is the same, what just happened to the force? It doubled. The force doubled. The force is twice as strong. If the force is twice as strong, this is like, you know, in the sci-fi movies, they have the tractor beam. Do you know that, tractor beam? Tractor beam is going to pull in that electron closer and closer because of the Coulombic attraction. And the same with this electron. This electron is going to be pulled in closer. You know, this is like the, what do they say? Well, anyway. It's like and so it's not gravitational. You know, there is a gravitational attraction, but the gravitational attraction is so small. That's we really ignore. It's electrical attraction that holds these together. Like the moon and the Earth would be held together by gravitational. The electron and the nucleus are going to be held by electrical. This is why electrical is the most important in chemistry. And so this is why hydrogen's bigger, because that tractor beam isn't as strong. Helium is a lot smaller. Even though there's more to it and it's going to be more dense, it's gonna pull it in. Okay, 16. I screwed this up. So on the test, I would have said, okay, A is 1, B is 2, and C is infinite. I would have fixed it during the exam. And then there are certain constants I would have given you on the test, but I write those on the board. So I would have written something on the board saying number 16, you know, and mark C if you choose infinite or something like that, you know. Okay. Because I made a mistake. What is it? Yeah, okay, infinite. 17.
True. No, false.
Is it true or false?
False.
The chemical properties are different, or the chemical properties are the same? They're the same. So this is false. False. Chemical properties are the same. I mean, you can't. Today you're breathing in. You're breathing in mostly oxygen 16, but you also breathe in a little bit of oxygen 17. Can your body use the oxygen 17, or is it poisonous, or what is it? Your body can't tell really the difference. I mean, yes, it weighs a little bit more, but how much is 1 AMU? Weight. Nothing. I mean, you'd need an awfully precise balance to tell the difference. 18. True. Memorization. 19.
False.
Good. 20. False. True. False. 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 Okay, I'm going to have to go against that because substances. What's the definition of a substance? Variable composition, substances versus mixtures. What's the difference between a substance and a mixture? Substances have fixed composition, like water. Water is a substance. Does water have variable properties or fixed properties? Like say, somebody might argue it has variable because Colorado, Denver, Colorado, does water boil in 100 degrees C? No, but you know what? It's elevation. So in LA, if you go up 5,000 feet in elevation, it's going to boil at the same. And so the properties are the same. So it's got fixed properties. 20 is true. Substances are what? You know, substances are by definition pure. And they're either, if it's pure, it's got to be either
Impure.
well, what is pure? You mentioned it earlier. It's an element or a... No? 21. B?
2.
2? Three?
Because it's subtraction, so you have to.
How many decimal places are we allowed? 1. And so, you know, the best thing is just do it. When we do addition or subtraction, we do it like this. Minus 1.1 equals what? And so all I have is 0. That 0, is it significant or not significant? It's insignificant, but I'm just going to add it there as a placeholder. So 2 minus 0 is 2. Well, this is uncertain, so I'm going to subscript that. And so this 2 is not allowed. 2 minus 1 is 1. That's allowed. 1 minus 1 is, how many figs is that? How many sig? That's 1. The correct answer is A. Hmm. 22. Well, electrolysis, did I talk about electrolysis?
No.
I did, you know, the exams are a little bit different because I don't do the same each semester, this class. And for this particular semester, I showed the electrolysis, how to separate hydrogen from oxygen.
No, we probably electrolyte.
It can be, but we have the electrolysis demo. I should probably show. And so, can you filter out the hydrogen from the oxygen in water?
Yes.
Filter, like.
No.
Let me just.
Still can't like separate them.
Yeah, you can put
Yeah.
batteries inside.
Yeah.
That's just like
Just like little.
Have you finished all?
No.
What chapter are you on?
I finished 3.
That's from 3.
4, 6, 5.
So much. No,
Oh, well, this semester I spent a lot more time talking about distillation versus, you know, distillation is a chemical technique or it's a physical technique. So I spent more time talking about distillation. But, you know, it depends on the particular semester. Like some semesters, this is a, well, it was broken. Is it still broken? No, it looks, maybe it's okay. So I did like a quick repair on this last time. But what I have inside here is I just have water inside this. How can I tell that the pressure in these 3 glass tubes is the same? Is the pressure the same? Actually, the water levels are different here. Do you see? The water level goes here, the water level's up here. And so the pressures are a little different, but it's okay. I can't go up any higher. And so all you do for electrolysis is very simple. Electrolysis is just, you could do this with batteries, like a 9-volt battery will be enough voltage to do this. But with electrolysis, you just pass an electric current through the water here. Let me just turn this up. And once you hit a certain voltage, the water will start to decompose. I don't know if you can see it, but it's really hard to see. Do you see the little bubbles forming? I'm going to let it run, so then we'll come back to it. All right, 23. $24. Okay, let's take a look at phosphorus on the periodic table. What's the symbol for phosphorus? It's element number 15. How many, so it's element number 15. Then, how do we know? It's element number 15, but it only has one isotope. If it only has one isotope, then the average mass is 30.9. The average mass is the mass of each and every atom of phosphorus in nature, so that's about 31, right? And so this has got to be P31. And so the answer would be what? The answer would be 16. 15 plus 16 is 31. 25. 26. A? Yeah. A is correct. B would be in milliliters. That's correct. There are different ways we could do this. Once you do a lot of these, then we just move the decimal place over. And so if you go from liters to milliliters.
27, I meant. This one didn't. 27 didn't make sense.
27 didn't make sense.
Same one.
It doesn't make sense because all these answers are wrong. And so you would say, the correct answer is not here. And so what I do on the board is I just write the correct answers there on the board. Well, just tell me what the answer you got is, or you would write it on the tab. What is it?
9 zeros and then 1.
I don't want it. I wanted something, a coefficient times the exponential. What is it?
I think it's the conversion unit is wrong. The unit. Probably. 17 probably.
Well, let me tell you what I'm doing here with this particular problem. I don't know if you see it. Do you see this problem? Let me tell you what I see here. When I look at that problem, I see 1.23 angstroms going to how many, what's it, 10 to the minus 12? Pico. So I'm going from 1.23 angstroms to how many picometers? And so what would it be? It'd be 123. And so what I'm seeing is this. I'm going from 1.23 times 10 to the minus 10 meters, which is an angstrom, to 123 times 10 to the minus 12 meters, which is a picometer. And so 1.23 angstrom is equal to 123 picometers. That's what I was doing in this particular problem. Yeah, this should be true or false. Is it true or false? True, yeah. True is correct. 29. False. Yeah. That was Rutherford. The only two people I want you to know for the discoveries was Rutherford and Thomson, and then Dalton for atomic theory, and then who else? Charles' Law, you don't have to have memorized. Charles' Law, because then you'd have to do Charles' Law, Boyle's Law, Gay-Lussac's Law, and there's more. So to be fair to all of them, we'll just ignore all of them. 30. Did you get false? What happens at 0 Kelvin? Things stop moving. Can you have negative Kelvin? There's no such thing. Like asking for negative Kelvin is like asking for a negative $20 bill. Does it exist?
True.
32. Well, true or false? Do you know who drove? Or?
False.
Okay. So 31 is true, 32 is
False.
false. Over 32? Actually, I can make this true. How can I make this true? what would I change? What word? I would only have to change one word to make it true. It makes sure hydrogen oxygen at 25 degrees has a lower
Higher.
kinetic energy. Oh no. Has a, actually two words I have to change. Well, you know, I could change this in different ways. So let's look at it in terms of potential energy. If I wanted to make this true, how would I do this? Hydrogen and oxygen, even though it has a lower temperature, should have a higher potential energy. Right? Definitely should have a higher potential energy. Will water explode unexpectedly at level of 4-story apartment building? No. Hydrogen can. And so if I change this to a higher potential energy, it's true. You know, these are the ways, you know, some people, what they do is they just memorize one answer, but what you do is you think of all possible scenarios. When you have multiple choice questions like this, the way you learn from multiple choice and the way you review it is by thinking about all the scenarios and all the twists you can do to it. And so in this particular problem here, what about in terms of kinetic energy? What would this be? Yeah, it has a lower kinetic energy. So if I change one word, but this is kinetic energy, then it's true. Does that answer the question or not really? Okay, how about this? What's the difference between kinetic energy and potential energy? Kinetic energy is motion. Kinetic energy is heat, temperature. That's it. If you have zero temperature, you have zero kinetic energy. If you have zero kinetic energy, you have zero temperature. Kinetic energy is temperature. If you look at the map, from theory, if you go to kinetic molecular theory and you look at the relationship, temperature is directly proportional to kinetic energy. This is a symbol for kinetic energy, or KE. What is the definition for potential energy?
The energy that came from kinetic energy and let's say.
Well, the potential energy doesn't come from kinetic energy. Kinetic energy is like heat transfer, so hot objects will transfer the heat. And of course you have the potential to be burned, so it is possible. But potential energy, the way we defined it, is not from temperature, it's not from heat, it's from yeah. I should do. My discussion now was a little. You know, I don't have enough time to go into it in detail. But let's say I have ice and I have water. So I have ice and water. This is at 0 degrees C. This is at 0 degrees C. Do they both have the same kinetic energy? Yeah, they're both at the same. Remember, kinetic energy is temperature. Do they both have the same temperature? Yes. Do they both have the same kinetic energy? Yes. What's the difference? The difference is in potential energy. In this case, the ice has potential to melt into water. In other words, if you melt ice and form water, then you have to add energy to ice to get it to melt. But when you melt ice, do you know what the temperature of the water that you formed is? What's the temperature of ice water? 0 degrees C. So if we go from ice to water at 0 degrees C, we have to add energy. If we go from water to ice at 0 degrees C, we have to remove energy. Well, that energy is the potential energy. It's not heat, it's not temperature, it's the potential energy kind of thing. That energy is going into changing the potential energy here. Does that make sense? This is potential energy for ice and water. What has potential to explode in the trunk of your car? You know? let's say you have a hydrogen-powered car, one of the hydrogen fuel cell cars. I've seen a lot more of those. In fact, I saw advertising. I was very tempted. I wanted to get one because Toyota had this advertisement. They're going to pay for your fuel for like 4 years, hydrogen. So I thought, wow, that's worth it. I'm going to do that. But what has more potential, a trunk full of water or a trunk full of hydrogen? Hydrogen. Do you expect? Wait a minute. They're at the same temperature. If they're at the same temperature, don't they have the same energy? No, it's not kinetic energy, it's potential. And hydrogen has the potential to explode, whereas water doesn't. That's the difference. And so it's just the potential for reactivity. You know, it's the same thing, you know, like wild. This could be overblown, but you know, it's like the great white shark versus the basking shark. You know, great white shark stirs fear in people. You know, maybe necessarily or unnecessarily so. I don't know, but it has the potential to, yeah, kill you. And so that's it's different. Things have different potential energy based on how they can react. Cars have the potential. Flights, you know, have the potential. And so in terms of chemistry, we look at combinations. So it's easy to tell which one has higher potential energy. Methane, this is the example I gave in class. And if this example I gave in class doesn't make sense, make sure to ask about it, you know. Ask about why there's a difference in potential energy. Methane and oxygen versus water and CO2. Both of these have the same kinetic energy because I put both at 25 degrees C. I'll just use the example I did in class. Both of these are at 25 degrees C, however, they're at different energies. Which one is higher energy? Even though the kinetic energy is exactly the same, one is a higher energy. What did I call this diagram here? Not energy potential diagram. I call it's not potential, it's the total energy. What did I call the total energy? I don't know. It's called I called it the internal energy. I don't know if anybody wrote it down, but if you wrote it down and you know it, you're way ahead of most people, like 99% of the people. You would be. This is a internal energy diagram or a total energy diagram, and so we're going to look at total energy. And total energy consists of PE plus KE. Good. And so we spend a lot of time talking about this. The thing is, we spend a lot of time talking about it, and hopefully by tomorrow you've seen it a lot of times. And then if you've seen it a lot of times, then you'll remember it. But if tonight is the night you're going to review, this is how I used to study. I crammed the night before. Then it's like overwhelming. You know, this is like an avalanche of information. It's just too much. And so this should be clear. This should be totally clear. And if this were on the test, I would consider it a give me problem. Give me problem is a problem that's discussed in class. I always thought those are give me problems because those are easy. Those were problems you didn't really have to think. Those are problems you just had to grasp versus challenge problems. Challenge problems are taking the material that was learned in class and then extending it beyond what was in class. Those are challenge problems. Those are nothing like the homework, nothing like what was presented in class. A lot of students say that's unfair, but unfortunately that's the way it's going to become in higher level. And so you get used to that. You get used to things not looking like anything that was presented in class. But going back to this is going to be a higher potential energy than this. And the example I gave was like a block, gravitational potential energy. A block up here versus block down here. I forgot. And so one way of thinking about this is by trying to visualize, you know, if you have a block of lead, you know, a block of lead up high hanging over your head is much even though kinetically it's not moving, it's got a potential to fall on your head and cause damage, versus a block on the floor doesn't have the potential to fall on your head and cause damage. And so, yeah. This is it. You know, this is a good opportunity. This is just the first exam out of 4 exams plus the final. This is just the first chemistry class out of maybe many for some. Maybe this is the last chemistry class for others. But now is the time to get that foundation, because I'll tell you, every quarter I was at UCLA, I went, whew, that was the hardest quarter I've ever experienced, you know? And you know what? The next quarter, even harder. And then finally I just gave up, you know? Each quarter is gonna get harder. That was my experience. And then how do you make your life easier? How you make your life easier is because for me, it was quite a challenge, because I'll tell you, my basic fundamental foundation was weak. I was comparing my basic knowledge compared to the people who were doing the top scores, and I was behind. It was like that marathon. I felt like I was like one of the back stragglers in the marathon, and I wasn't going to catch up. And so I had to do a lot of extra work to catch up. But still, it's not too late, you know. So if this exam doesn't go the best, you know, you still have a chance to catch up and do really well in the class. So. But it just means going back and going through this stuff. But anyway, we're time for a break. So let's take a break and then we'll continue, or we can work straight through if you want. Okay, we'll take a break. But you know, this is from experience.